ABG looks complicated? Not anymore. I'll teach you a simple 4-step method to read it. An arterial blood gas gives us a rapid picture of acid-base balance, ventilation, and oxygenation. The first thing we check in any ABG is the pH. It tells us whether the blood is acidic or alkaline. The normal arterial blood pH is 7.35 to 7.45. Think of this as our safe zone. Below 7.35 is acidosis. Above 7.45 is alkalosis. Simple. Next, check PaCO2. Its normal range is 35 to 45 millimeters of mercury. Now check HCO3. The normal range is 22 to 26 milliequivalents per liter. Finally, check PaO2. A normal arterial PaO2 is approximately 80 to 100 millimeters of mercury. SaO2 tells us arterial oxygen saturation. The normal range is 95 to 100%. Remember the four looks. pH, PaCO2, HCO3, and finally oxygenation. In respiratory disorders, remember this: pH and PaCO2 move in opposite directions. In metabolic disorders, pH and HCO3 move in the same direction. Low pH plus high PaCO2? Think respiratory acidosis. High pH plus low PaCO2? Think respiratory alkalosis. Low pH plus low HCO3? Think metabolic acidosis. High pH plus high HCO3? Think metabolic alkalosis. When acid-base balance is disturbed, the body tries to compensate using the lungs or kidneys. Here's a case: pH 7.22, PaCO2 55, and HCO3 25. Low pH, high PaCO2, and normal HCO3. The answer is respiratory acidosis. pH 7.50, normal PaCO2, and high HCO3. This is metabolic alkalosis. Low pH and low HCO3 moving together. This is metabolic acidosis. Low normal range pH, high PaCO2, and high HCO3 suggest compensated respiratory acidosis. Low pH, high PaCO2 with elevated HCO3, the kidneys are compensating. High normal pH, high HCO3, and elevated PaCO2. This is compensated metabolic alkalosis. Severe acidemia with very low HCO3. This is metabolic acidosis. Low pH, high PaCO2, and low HCO3. This is a mixed respiratory and metabolic acidosis. The pH is near normal, but PaO2 is 55, and CO2 is 88%. That's hypoxemia. If the ABG doesn't fit the clinical picture, don't force the diagnosis. Repeat the ABG. Anion gap is the difference between sodium and the measured negative ions, chloride plus bicarbonate. The anion gap is calculated as sodium minus chloride plus bicarbonate. This helps us interpret metabolic acidosis. Why do we check it? A high anion gap can point us toward unmeasured anions in metabolic acidosis. Your turn. pH 7.30, PaCO2 40, HCO3 18. What's the diagnosis? Remember, pH, PaCO2, HCO3, then oxygenation. 4 looks can make ABG interpretation much easier.